Ladies and gentlemen, this is Rudy, your host for today's webinar. Thank you for standing by and welcome to ISRI India on GIS and IoT Harness the Full Potential of Real-Time Data. In today's webinar, we will explore how the right spatial context of your real-time data streams enables deeper understanding and better decision making. The speaker for today's webinar is Mr. Prashant K. Prashant is currently working as a group manager, pre-sales at ISRI India with a focus on real-time and big data analytics on GIS. He is an ISRI certified professional and has more than 12 years of experience in GIS domain across a range of industries including commercial utilities, transportations, and education. For the duration of presentation, all participants' line will be in listen-only mode. We also have a panel of ISRI India experts on call to answer any queries you may have. We will have the Q&A session post the presentation. Meanwhile, if you have any questions, you may also send them across to all panelists using the chat window on the right-hand side of your console. In view of COVID-19 lockdown, our teams are hosting this webinar from their home environments. We have planned this event to ensure minimal disruptions to the service. In case we face any unexpected disruption, please be patient. We would take necessary steps to restore the service immediately. So now, without further delay, I would like now to hand over the proceedings to Mr. Prashant from ISRI India. Mr. Prashant, welcome to the program. We are now ready to begin.
Thank you, Rudraji. Good morning, one and all. Hope you're all doing good and are staying safe and healthy. In today's webinar on GIS and IoT harness the full potential of GIS data, I'll be giving a brief introduction on IoT, location intelligence in IoT and its application areas, some of the challenges we face and ISRI offerings on IoT and real-time analytics, highlights and capabilities with some demonstrations. And the Internet of Things. Okay, as an introduction, Internet of Things can be something very different depending upon whom you ask. For most consumers who think about IoT, it's a connected home or smart appliance or maybe being able to control the thermostats from the cell phones. From a utility company perspective, it's a networked sensors on their transmission and pipelines, wireless meters that can be read remotely with safety and operational intelligence. From a local government perspective, it is being able to monitor, route, and communicate with emergency services. It's embedded sensors in roads and bridges to detect structural damage or hazardous driving conditions. It's in the infrastructure to help their citizens with service requests. For military and intelligence community, there is surveillance applications, live battlefield through positioning and health monitoring. There is connected device and increasing IoT focus in agriculture area as well. Tracking on livestock, sensors to detect proper soil conditions or irrigation automation, etc. We are seeing tremendous growth and opportunities in shipping, travel, and telecommunications, public safety, natural disaster alerting, nearly limitless business implications, and the list of potential applications just continues to grow. So all those interpretations of IoT are correct and has a location component to it. You can see various sectors like weather, environment, transportation, communication, health and safety with their business data, along with location intelligence can provide a better insight of the problem and decision-making power. GIS provides a platform to bring these real-time information for analyzing, monitoring, and disseminating information to various stakeholders. Because location is such a crucial facet of IoT data, many organizations and business find that modern GIS fed by real-time data can be a powerful tool for operations. By ingesting, processing, analyzing, and visualizing tens of thousands of several million events per second, real-time GIS empowers decision makers and stakeholders with latest information and give insights of what they need to act immediately and also for future ideas and strategies. It takes IoT's high velocity, high volume data and brings it to life by revealing patterns, connections, and opportunities that are difficult or impossible to interpret, and enable with a speedier next generation level of decision making and problem solving capabilities. If you see some of the important use cases where IoT with GIS and the location intelligence plays a major role. Some of such examples are asset monitoring, personal tracking, anomaly detection and alerting, actuation in some IoT sensors, etc. Where agriculture, as I mentioned before, as agriculture sector uses it for soil and crop monitoring, air quality monitoring, etc. In the current era, connected cars and operation monitoring, SCADA integrations in the utility sector are all different use cases where IoT is being used. To achieve these mentioned use cases and take advantages of data produced by sensors, we would need to do three fundamental things. Ingest data being broadcasted by the sensors, process the data in real time, often trigger alerts or actions, and the third is to store and analyze massive amount of those observations data over time to derive patterns and take future decisions. So the system should enable us with high velocity ingestions and handle high volume data. Most of the discussed use cases are mission critical in nature. Hence, the system should be highly available, resilient, and scalable. To cater the need of an organization to implement real-time GIS, ESRI offers two different product components. One with ArcGIS Enterprise as an on-premise implementation with GeoEvent server. The other as a SaaS offering on ArcGIS Online, the ArcGIS Analytics for IoT. Depends on the deployment scenario and organization's need. One can select appropriate component. I will be covering more details about both the products in the upcoming slides. So as you can see in the current slide, it is giving the capability where GeoEvent server covers the real-time data management, ingestion, processing, and dissemination, and it is an on-premise or a tenant cloud deployment, wherein ArcGIS Analytics for IoT having capability of IoT and big data analytics with capabilities of real-time data ingestion, processing, and analysis, and it is a SaaS model. So those who are hearing from us about GeoEvent server for the first time, it is the specific server role just like GIS server, part of large ArcGIS Enterprise platform. And this product provides support for real-time GIS, specifically the data ingestion, analytics, actuation, storage, and visualization of real-time data. GeoEvent server is able to consume streams of data from nearly any source, whether it's tracking of moving objects like ships, LSNs, mobile devices, or stationary sensors like gas, electric meters, string gauges, or air quality sensors, to things that just happen like accidents or even lightning strikes. It allows you to take all of that incoming data and provide streaming analytics, spatial and attribute-based enhancements or enrichments, as well as pattern detection, making sense of types of high volume and high velocity data that our users are receiving. The new storage solution, in conjunction with ArcGIS Data Store, which is a component of ArcGIS Enterprise, in the form of Spatiotemporal Big Data Store, created new ways of visualizing live data through stream services. And both live and historic data are discrete or aggregated views for use in web apps or maps, and recently through desktop application called ArcGIS Pro. Also, this component allows actuation and notification, closing the loop as it were, being able to send the data back out of our system, not just through the ArcGIS platform, but through ever-expanding Internet of Things. Now, if you go to the details about ArcGIS GeoEvent server capabilities, it has three different components. One is the input connector, through which you will be connecting to any live data streams. So there are many out-of-box connectors available in ArcGIS GeoEvent server. You can see on the left-hand side, like feeds coming from different broadcasts in the form of JSON, GeoJSON, XML, Rust endpoint, WebSockets, TCP or UDP socket, normal CSV files or GeoJSON or JSON files in a folder, etc. can be taken. Apart from that, we have our own gallery as well as partner gallery, which is customized to get feed from different sources like AWS IoT, Azure IoT, or vAlarm, etc. Now coming to the processing part of it. So GeoEvent service is the component which connects between input and the data dissemination part, the output connector. On the right-hand side of the presentation, you can see the output connectors, which is out of box. Again, you can push the data into different features like update a feature, or as a stream service you can push, and applications can just subscribe to that and get the real-time data on board for monitoring and decision making. It also has a couple of partner galleries and our own custom-made galleries of connectors to disseminate the data. When you combine both input and output connectors together in GeoEvent service, there you have a lot of filters and processes like our geoprocessing components does. So by configuring a model builder kind of workflow, you can connect to the real-time feeds and process the data on fly and disseminate it accordingly. And this specific portion gives you clarity on how the GeoEvent service works. So as I mentioned in the previous slide, you can see the green colored box, which is an input, and the yellow boxes are representing the filters and processors. There are out-of-box processors and filters available to configure. So according to a specific criteria met, you can disseminate the output as an alert or as a notification or as a stream service or a feature update to the dashboard or web applications. And this can be further extended with customization. I will quickly go to a demonstration, and due to multiple machine engagement for a seamless flow, I have created a demonstration and recorded it as a video, and I will be playing that. And the use case of this specific demonstration is about indoor navigation, where you have a facility, you need to find out there are restrictions where people should not enter. So how you can get alerts, and this tracking is being done using RFID integration. So you can see this is my ArcGIS Enterprise portal, which is federated with my ArcGIS server. So obviously you should have ArcGIS server, and on top of it only the GeoEvent server component will sit. And for content management, I have portal for ArcGIS. So it is federated, and now I have the GIS server component. I received my services here in the GIS server component, and this is my GeoEvent manager where GeoEvent service which is being configured. You can see the count increasing where the feed is coming. So the green color box is the input where I can get the feed, and the whole workflow tells you you have to configure the outputs as well as inputs with couple of processors and filters. You can see on the left-hand side panel you have filters and processors, those yellow boxes. So I have configured a geotagger processor and have done a filter to find out any specific person who is entering to the building falling into a specific geofence area. So this is a dashboard created out of it, wherein you can see a facility, larger facility, and the multicolor dots are moving. Those are 4 different employees in the facility with a specific RFID. You can see the person entered into a specific restricted room, and you get an alert, and where it is being entered, that notification is being pushed. So this is the restriction room, AHU room, and you can see the total number of alerts. And once you have all this information falling, you can analyze it for footfall analysis, which location, whether it is the lobby or in conference room, you get more footfall that can be analyzed, and that is also displayed. And this is per meter square footfall which has happened. And you can see alert details where the person is being entering, and that can be either configured into a dashboard or to an email. So it can be either way, like how you want to configure it. You can even subscribe to an SMS, and that also can be pushed as a notification. Going back to the presentation, there are a couple of resources available regarding GeoEvent server. So you can see there is an updated release of 10.8 in which couple of modifications we have done. On the GeoEvent service panel itself, you have control to go to your input connectors and output connectors, as well as a small snippet of data can be monitored directly while configuring whether the data is coming properly or not. That flow is being integrated, and there are updated documentation which we have done, and there is a quick start PDF also, installation guides, system requirements, and tutorials available. And there are a couple of links, like you have a specific GeoEvent forum where organizations work in real time with GeoEvent. There are a couple of discussions posted where even users post their problems and we give a reply. So this forum will help, or the blog will help you to find out different solutions to the bottlenecks what you face in the implementation. And there are video records available for the technical workshops as well. So to summarize about GeoEvent server, it is on-premise or cloud real-time spatial data ingestion, filtering, or processing data dissemination platform, and which sits on top of ArcGIS Enterprise. So if you ask me, is there a better option that provides improved scalability and disaster recovery? Because when you say on-premise, yes, you have to take care of your own infrastructure. You have to do all the management of the deployment. So the option is, yes, I do have another platform as a SaaS offering, which is called ArcGIS Analytics for IoT. So you can see the link about the product. You can get the overview. And This product's capability takes advantage of the contemporary technology advances of geospatial cloud and extends the capability of real-time and big data functions. It's a hosted, managed SaaS that enables you to access, analyze, and act on any kind of observation data. Behind the scene, it runs on Kubernetes and a container driver architecture. That means it can achieve the level of scalability and resiliency that we never really able to achieve before. So the capabilities of analytics for IoT are surfaced through few new user types. You can see on the product capability page, ArcGIS feed item allows users to receive sensor info. Its real-time analytic item allows you to perform real-time processing of those inputs, including triggering alerts and actions. And with the big data analytic item, user can access the access and analyze the big data repositories of historical observation which has come to the system. Analytics for IoT is typically connecting to industry IoT cloud platforms or third-party repositories of data. And it does not typically connect to IoT sensors themselves, although sensors could be configured to push data, attain Linux for IoT over REST endpoint. Now, the feeds and analysis that you configure are managed by Analytics of IoT web application. Analytics for IoT is very much an engine. It is a system that runs real-time and do big data jobs, and the app is an authoring experience for those capabilities and the new item types, feeds, real-time analytics and big data analytics essentially map back to those three IoT challenges of integration, or challenges of ingestion, alerting, and analysis. ArcGIS analytics for IoT capabilities begin with a feed, which is ingesting a real-time sensor. Obviously, the input is a feed, and this feed typically connects to external sources of observational data like Internet of Things platforms, message broker, or third-party APIs. Feeds, in their essence, parse incoming data, whether it's tabular, point data, polyline, or polygon data, and they expose it for analysis and visualization in ArcGIS. A feed is also a type of stream layer and can be added to a map to see new information as soon as it is received. And then you can use feeds and real-time analytics to do processing and alerting. A real-time analytic is a long-running job that continuously operates on data coming in the form of feed transforming and enriching, detecting incidents, and even taking action. Real-time analytics can also bring in data from static data sources to be used for enrichment, geofencing, and data joins, and then within a real-time analytics, you can combine different tools together in a workflow to ask any number of questions and associate different output behavior with each question. Real-time analytics are useful when your decision timeline is operational. So when you need to know what something and take an action immediately. In such scenarios, real-time analytics will be helping you. It also coming with the big data analytical capability. Big data analytics analyze the data you store over time. In many cases, data that you may have stored using a feed in real-time analytics become huge, and that become a big data for your analysis. A big data analytics is a specific job that fires up and runs on the designated stored data, analyzes trends, and then pushes out the result. It is just like a real-time analytics in that you combine different tools together. It's a complete workflow. So similar to GeoEvent server, where we define a workflow kind of thing where input and output connectors and different processors we combine. But in big data analytics, you work with stored information and accept fast real-time data. And it's important to note that same output are available for big data analytics. So you can take automated action on your IoT system based on overall system status. So big data analytics are useful when your decision timelines are tactical, when you need to make a decision regularly based on standard practices, or they are useful when your decision timelines are strategic, when you need to learn over and adjust border policies. So the spatial temporal analysis offered with analytics for IoT is varied and largely aligns with the tools available through GeoAnalytics. These tools leverage GeoAnalytics algorithms as is and run them in the analytics for IoT environment. There are also some additional tools here that are specifically oriented for tracking and pipeline building workflows. For example, Calculate Journey, you can see in the tool list, is a unique tool to analytics for IoT that allows you to divide up track-based data into polyline features where an entity was moving and point feature where an entity with staying still. There are additional tools as well, like doing simple filtering, mapping schemas from one form to another, selecting or retaining certain fields, and merging different pathways in an analytical pipeline to others. These are particular to analytics for IoT because these are specifically geared towards building models and having an analysis conducted over multi-step process. All of these tools that you see here work in big data analytics, and those that operate on a single message at a time will also work in real-time analytics. And what we mean by that is that some tools that calculate fields can operate on a single message, calculating the new field on single message and continuing the message down the pipeline, and other tools may, by their nature, to operate on set of features at once. For example, finding hotspots. Generally, we do it for a global average across set of data. You would never run a find hotspot tool on real-time data because you do not find any hotspot on a single message individually. It will be a global pattern generally. So more and more of these tools will be adapted to work in real-time analytics over time. Now coming to the various inputs and output types, ArcGIS for IoT in the current release supports variety of different types of input streaming data. So some of these types include bringing data from future layer, receiving data from IoT cloud platforms like Azure or AWS, pulling data from third-party APIs and number of message brokers as well. But there can be additional external cloud functions that translate data from even more sources into one of these compatible feed types. That is an opportunity for a developer on this product. Likewise, the same could be done for input sources for static data and for writing two different types of outputs. I want to cover the licensing, how it works for analytics for IoT. This is offered as an annual subscription on top of ArcGIS Online, and it is purchased for each organization individually. It is also an overall capability for an organization as it supports several simultaneous real-time and big data use cases or missions. It is not sold by number of named users because the underlying compute capability that is needed. So it is impossible to sell as individual named user. Analytics for IoT is more directly related to those use cases which we mentioned before and data velocities as opposed to the number of users. So what does this mean for ArcGIS users? As analytics for IoT is managed by web application, we will see that in the demo, and this is an authorizing environment for new real-time in big data items. This web application is available to any creator or GIS professional user in the organization. I believe you understand the different user types what ArcGIS platform supports. And the app is what allows you to do the things you will see in the demonstration coming. Like configure a feed, that is the prime thing in the initial step, to receive a sensor observation and configure a real-time analytic to process those observations to detect incidents and send alerts. So this application is available to any creator and GIS professional, but it is governed through the privileges. So your administrator will be having control over who can access analytics for IoT and create these processes. Now, the analytics that these users author and run can generate different types of outputs. Products like stream layers to feature layers and map image layers. And these are available to all users in the organization to monitor, explore, and use in different ArcGIS client apps. So, analytics for IoT is a real-time and big data capability for the organization, likely managed by few, but making IoT insights and decision-making available to everyone. And as a subscription for Analytics IoT follows the same business rule and policies of ArcGIS Online, meaning its end date will be typically aligned with your overall subscription end date and renewal activities will happen together and so on. Now we will see this product and this works in action. We will begin with real-time capabilities and of the product and take you through how you do real-time data ingestion and analytics on IoT data. So I will, as I mentioned before, I will just
Many of our users today are working with real-time and big data from different types of sensors for workflows that range from situational awareness to incident detection to trend assessment. For example, this is a dashboard of transit information in Charlotte, North Carolina. We are looking at a variety of data streams here: public transit, micromobility, social media, and autonomous devices. These larger moving tracks are the city buses, traveling around on their route shown in green. These stationary sensors are the city's public bike stations, showing the numbers of available bikes, where lower numbers of bikes are shown in red. And these update every few seconds. These smaller green tracks represent connected vehicles whose locations would be picked up by roadway sensors. In this case, it's autonomous device data being replayed. And this hexagon layer that you see in the background shows the count of Waze alerts that have been reported in the last few days. This type of layer dynamically displays on-the-fly aggregations, so you can see patterns more easily. In this case, we're looking at the count of alerts, but zooming in, we can also display the raw features to more easily differentiate between types of alerts. And all these information products provide situational awareness and insight. Now, many of our users are already leveraging GeoEvent and GeoAnalytics server to access and analyze observation data. And this is often really difficult work. Each data stream is unique and brings its own challenges, especially when you're integrating feeds across the entire organization. Sensor data comes in at high velocities in some cases, which means you need to be able to scale your infrastructure and then deal with large collections of data. And you typically need dedicated staff to manage the environments and to ensure that they're resilient. Today, I'm excited to tell you about a new capability for Esri's geospatial cloud. ArcGIS Analytics for IoT changes the game for real-time and big data location analysis. It's a hosted managed SaaS, which enables you to access, analyze, and act on any kind of observation data. It runs on a Kubernetes container-based architecture, which means that it can scale to massive velocities and volume, all while providing advanced spatial analysis. Let's have a look. Analytics for IoT is an authoring environment for feeds and analytics. It not only ingests information, but transforms it, enriches it, and acts upon it. The first thing we're going to look at is creating a feed. Creating a feed is a guided experience that's designed to help you bring in your real-time data successfully every time. You get started by choosing what type of feed you want to create, whether it's coming from ArcGIS, a cloud platform, or a web and messaging system. We're going to bring in that bus data, which is GTFS information that's being replayed to an Azure Event Hub. Analytics for IoT integrates with cloud platforms like Azure and AWS to bring sensor data into ArcGIS for spatiotemporal reasoning. The first step to creating a feed is providing the connection information. For an Azure Event Hub, this includes the shared access key, the endpoint, and the entity path. Once the connection is established, Analytics for IoT reaches out to that stream of data, samples it, and derives the schema for you in one step. And you can proceed to make changes from here. You can adjust field names, you can fix field types, and you can drop fields that aren't necessary. Next, you tell Analytics for IoT about the key properties of your data. This includes the geometry, which for the buses would be latitude and longitude point data, the date information, which in this case is coming from a single field, and the track ID, which for the buses would be the route. And that's it. We'll go ahead and give this feed a name like City Buses and save it to our account. A feed is a new type of item in ArcGIS. It encapsulates all this connection information, the parsing details, the schema of the data, the key properties, and it's running in the cloud. With Analytics for IoT, there's no need for infrastructure or system setup. All you need is a web browser, and you can connect to your real-time data and immediately get to work. Feeds are a type of stream layer, so you can add them to a map and visualize your real-time data. We'll go ahead and add this feed to a map and have a look. Now I'll zoom into the Charlotte area. Since this is a stream layer, as soon as the information arrives at the Azure Event Hub and is accessed by Analytics for IoT, it's pushed to the map immediately. So there's no need to continuously pull the dataset for the latest information. This is the same stream of bus data that we were looking at in the dashboard. So feeds enable real-time data ingestion and provide visualization and situational awareness. You can also perform real-time analysis on data coming in through a feed. Analytics for IoT is an engine that interprets and acts on observation data. Let's take asset monitoring as an example. Many organizations that track vehicles and personnel want to know when those assets leave a work area or if they deviate from an expected pattern. Now, in some cases, it could mean that they're just completing their work for the day, but it could also indicate risk or danger. Right now, we are simply monitoring these buses as they travel around on their routes. But with real-time analysis, you can also detect and act on deviations. Real-time analytics are what you use when you need to know about something and act immediately. You put them together by connecting feeds to tools and asking questions and connecting answers to actions. This real-time analytic calculates the distance of each bus position to its assigned route. And if that distance is above a given threshold, it captures that observation as a deviation. So let's have a look at the results of this analysis. Over here in the Northwest, we see that a couple of city buses traveled on roads that aren't part of their assigned routes. And over here in the southeast, we see that a city bus traveled on roads that aren't part of any bus route. This kind of information illuminates incidents that you might want to investigate more deeply. And with analytics for IoT, you can configure output actions, such as sending an email alert to a transit manager. Now, in addition to enabling you to analyze data in real time, with analytics for IoT, you can also analyze the data that you have collected over time using big data analytics. Big data analytics enable you to assess patterns on a broader scale. And with analytics for IoT, you can schedule them to run on a regular basis. Let's look at road and lane closures as an example. Many cities provide information to their citizens about road construction projects and the associated road and lane closures. But citizens are also increasingly acting as sensors and are reporting information about road closures through apps like Waze. These are all the road and lane closures that have been reported by Waze users in the last few days. And immediately we could see that some of these reports don't match up with projects that the city has approved. Using a big data analytic, we can compare these two data sets in multiple dimensions. This analytic takes the approved construction projects and the Waze reports and analyzes them in both space and time to identify whether each Waze report matches up to an approved road project. This analysis also scores the Waze reports based on proximity and other criteria. Now, let's look at some of the analysis results in the map. We can see that some of these reports are now scored differently. The Waze reports in blue match up perfectly with a road construction project that the city has approved. The ones in orange don't match up with a project spatially, but they do match up in terms of time and street name. So these are probably just cases where the Waze user didn't click the button fast enough as they passed through a road or lane closure area. The remaining points in red represent Waze reports that don't match up with any city-approved projects, such as this example on 7th Street. But in other cases, the Waze report does match up with a project spatially, but not in terms of time. For example, this Waze report came in from a user on the 8th of April, which is a day after the project was supposed to have been completed on the 7th. Now, what we are really doing here is identifying anomalies in space and time. And the power of analytics for IoT is that you can scale your big data analytics to run against hundreds of millions or even billions of features, teasing out irregularities from expected patterns. And these analytics go beyond ad hoc processing because they can be scheduled. This analytic is scheduled to run every 5 minutes, accessing the latest city data and the latest Waze reports each time, and can be tipping off officials to where enforcement may be needed. Let's think about that for a second. You can schedule your big data analytics and turn any geospatial tradecraft into an automated service that evolves with new data, scales and triggers action, and all without writing a single line of code. Now, more broadly, all these feeds and analytics are driving information products that provide situational awareness and insight into behavior. ArcGIS Analytics for IoT brings real-time and big data capabilities as a service to Esri's geospatial cloud. It's hosted and managed for you, so that automated data ingestion and analysis is easier than ever before. So what do you think? How could you use analytics for IoT to unlock the power of location in your IoT?
As you see in the video, now we are really doing here is identifying anomalies in space and time, and as a power of analytics for IoT is that you scale your big data analytics to run against hundreds of millions and even billions of features, teasing out irregularities from expected patterns. And these analytics go beyond ad hoc processing to work in real time because they can be scheduled. And this analytics is scheduled to run every 5 minutes, accessing what you have seen. So similar application can be configured for your city with ArcGIS Online and Analytics for IoT if the government provided sensor feeds are coming, multiple feeds or multiple sources which is coming into your system that can be configured, and you can schedule your big data analytics also and turn any geospatial tradecraft into automated service that evolves the new data and scales and triggers an action. So now, okay. To summarize what we have been seeing in the presentation, so that rounds out the product overview for today. Analytics for IoT, very suited for sensor observation data, more generally brings real-time and big data capabilities to ISRI's geospatial cloud, and these capabilities can be summarized in these 6 categories: ingestion of data, visualization, which is in terms of both real-time layers and dynamic aggregation layers, analysis, especially in terms of geofencing, incident detection, and trend assessment. And lastly, ArcGIS offers ArcGIS for IoT also offers alerting mechanism and automation of output actions, including talking back to the external system or actions. So this was a capability available with GeoEvent as well, depending upon the IoT sensor. So similar way it is available with analytics for IoT. And before wrapping up, I want to intimate you, and we urge you to register and participate in our upcoming webinars on 27th on NV for extracting information from remotely sensitive data, and on June 4th a session on NV and SARscape for advanced imagery analytics. And last but the least information which I want to pass it on you about our initiative while we undergo this pandemic situation, that now gain free access to ArcGIS Online and 20 plus apps until 31st August 2020, including ArcGIS Pro and lessons to learn ArcGIS and the ISRI Academy.